สวัสดีค่ะ I'm Yara.
And I'm Rob,
We're excited to introduce the evaluations framework
a new framework that measures the quality of your intelligent features.
so you can deliver your apps with confidence.
Last year, we introduced the Foundation Models framework, which helped you add intelligent features to your apps using our on-device models. The same models which power Apple Intelligence. Building app features with generative AI poses new testing challenges because the same input can produce different outputs. These models break a contract that is fundamental to software testing. Consider traditional software where a particular input always produces a particular output. You can easily verify this behavior with a unit test. You're guaranteed the same input will produce the same output on any device, including your customers. With intelligent software, you cannot rely on functional consistency to verify behavior, which means that unit tests are insufficient. Unverified behavior can erode customer confidence. Your customers expect intelligent features in your app, like any feature, to be safe, trustworthy, and reliable. Shipping a feature with unpredictable behavior can have adverse consequences on your app's reputation. It's important we measure our intelligent features and understand how they respond to different inputs. And since functional tests can't verify probabilistic behavior, we need a new form of test that is more robust. We need to know, how often does my app produce unexpected results? How often does the agent take an unexpected path to generate answers? And under what circumstances does the feature produce unsafe results? The challenges of testing intelligence features powered by generative AI is exactly why we built the evaluations framework. The evaluations framework is a flexible system of provided types and protocols. This video will focus on evaluating intelligent features powered by language models. But you can evaluate any stochastic system, such as classifiers and linear regression models. Yada and I will introduce you to several types in the framework. We'll cover data loading and building a diverse data set, building quantitative metrics with evaluator and metric, and refining your measurements using model judges and score dimensions to create qualitative metrics. In this video, you'll get started with evaluations. After building your first evaluation, we'll show you how to scale that evaluation with more data and more measurements. Then we'll teach you how to build powerful model judges using our simple API. Let's get started with evaluations. Yada and I are building an app called Book Tracker. We both love books and wanted an app to manage our libraries. Yada just added a new feature called Book Tagging Service. It automatically tags books based on a review we've written in Book Tracker. I can't wait to open Xcode and try it out. Let's add a playground macro to booktaggingservice.swift. Here's the review of Pride and Prejudice Yada added to Book Tracker. I have to say, I'm a fan myself. Let's see what tags we get back. This is a good start, but as I'm reading some of the tags, I can see our service will need a little work. 9 tags is more than I was expecting. And I don't want the book's name as a tag either. Multi-word tags are going to be a problem in the UI, so we should avoid those as well. Let's see if we have better luck with another review, Dracula. 7 tags is within our expected amount. Let's take a closer look at them. There are some behaviors that I'd like to see more of. It identified literary genres and some categories that would help me browse a larger library. Okay, we've just completed our first evaluation of the service. We created a list of expectations and used our human judgment to measure how the service performed. Every evaluation measures how well an intelligent feature performs against our expectations. Unfortunately, human judgment doesn't scale. But we've created a way to automate and scale evaluations. All you have to do is add import evaluations and implement the evaluation protocol. Let's build an evaluation in code. And we'll start with our first expectation, measuring that our service generates the correct number of tags. There are 5 steps to building and running an evaluation. You define what code you're measuring. Then, define what data you're sending the code. Next, define what measurements you're making and how. Then summarize your measurements. And then finally, create a test to run your evaluation. First, we add the call to the book tagging service and return its output inside of the subject from method. These generated tags are the subject of our evaluation. Next, define the input samples we'll feed the code we're measuring. Then, we'll use model sample to wrap the same reviews we tested in the playground earlier, Pride and Prejudice, and Dracula. Notice we define expected tags as well. These are the ideal tags we'd like to see from the service. Now, it's time to define our measurements using the metric type. We add a metric called tag count, which will track the number of generated tags returned by the service. We need something to measure the generated tags. Evaluator takes a closure that gets past the output from the service for a given sample. We could check the number of generated tags by using the count of the tags property. If the length of the tags array is between 3 and 8, we return a passing metric from our evaluator. If not, we return a failing metric. Evaluators run over a single sample at a time, but we can measure trends and look for patterns measured over all our samples in the aggregate metrics using method. Let's calculate the average number of times the service generates the correct number of tags. Then we'll have a ratio for how often the service behaves correctly. Okay, we've written our first evaluation. Next, let's write some code to run it. Evaluations integrates with Swift testing, so you can run your evaluations in your app's test targets. Here we instantiate our book tagging evaluation inside of a test suite. We add some notes to our evaluation run so we can keep track of the configuration we're evaluating. This will be helpful later when we compare across different evaluation runs. Next, we add a test function using the test macro, and a new test trait, evaluates. This trait takes our evaluation in a notes dictionary, like the one we created earlier in the suite. Inside our test, we can access an evaluation results bundle. This contains all of the metrics and aggregate metrics from our evaluation run. Let's grab all of our tag count metrics from the results and assert against its average value. We'll use the aggregate value method on the results bundle. Then assert against the expect macro. Here, I expect the service to produce the correct number of tags 80% of the time. Why 80%? If the service performance dips below 80%, I want to know, and a failing test is a great signal. But what if I want even more insight into what happened during the evaluation? We have a new test report for evaluations. It's a great way to dive into the details of your evaluation and analyze further. Let's run our test, and I'll walk you through the report. Based on what the service returned earlier in my playground, specifically how many tags it generated for Pride and Prejudice, I don't expect the test to pass. Okay, the test didn't pass. Let's go to the report and review what happened. Click on the Report Navigator and then select Evaluations in the test report. Here's the evaluation report for the test suite. Let's double-click the row to find out more. And I see my tag count metric only passed 50% of the time. And a quick look at the full results table shows me that my Pride and Prejudice sample produced a failure, but my Dracula sample produced the correct number of tags. I can select each row in the table to see more details, using the Assistant Editor in Xcode. The Detail panel shows the prompt and each measurement for the model sample. At the bottom, you see the entire response from the model. Let's recap a little. We built an evaluation for book tagging service, ran that evaluation, and it failed to meet our optimization target. Remember back in our test definition? This is where we defined our optimization target. We're saying the feature behaves as expected if the correct number of tags were generated 80% of the time. Beyond the automated check of our optimization target, we need to analyze deeper into our results and gather insights. Specifically, think about the changes that could be made to improve the feature's performance. I have a hunch, so I look back at the generable type, book tags, that the service is generating. We already have a guide macro giving the model additional instructions for the tags property. I could specify a count property in that guide, which can take a range. That should instruct the model to only generate between 3 and 8 tags. This is an interesting theory. Let's make that change. Then rerun the evaluation to see if I'm right. We call this process hill climbing. All right, I made the change and I reran the evaluation. My test passed and my tag count passes 100% of the time. But I notice a potentially strange behavior. After my change, the service always generates 8 tags. Now that we have the evaluation set up, let's collect more measurements across more samples and let's see if that strange behavior persists. We started our evaluation with only 2 data samples. As we saw, that only gave us 2 measurements to extract trends. Good evaluations have thousands of samples to extract trends, but also to exercise your feature in many different ways. We should consider variety in our dataset. For example, we want the service to recognize different genres. We can't assume every user will give it a verbose review, so our reviews should be different lengths. You browse for fiction and nonfiction using different categories. Your sample should represent that variety. Finally, you should consider different forms: novels, short stories, and essays. Let's make it hard on the model too. Sprinkle in personal opinions so we can measure how well the service ignores those in the reviews. If you want to teach the feature how to write tags like you, start by including more of your personal style in the expected values of the samples. Let's look at a few examples in code. This review of The Secret Garden reads very different than the reviews we started with, because we wrote it as though we were an avid gardener. Here we challenged the model, including a personal review from a mother reading Treasure Island to her son. Lots of personal opinions in this review. This board game enthusiast needed multiple paragraphs for their review of the Chinese classic, Romance of the Three Kingdoms. While this casual reader described a famous British detective's sidekick in a single sentence. The game is afoot when the model tries to decipher this one. And while it's fun to come up with these examples, human data creation doesn't scale either. Consider these sentence completion pairs, where the output of the feature is compared directly to the expected answer. You need thousands of examples for this evaluation to be effective. Fortunately, we include a sample generator as part of the evaluations framework. You could call it directly on an array of model samples, and it will synthetically generate more samples using a model of your choice. To hear more about how you can synthesize larger data sets and learn more about advanced uses of model sample, please check out our video, Create Robust Evaluations for Agentic Apps. Back to book tagging. I'm going to update my dataset property to include all of the book reviews from our library, including the 4 we showed earlier. When I rerun my evaluation with the expanded dataset, my test passes, my tag count average is still 100%, and the service generated 8 tags for all of them. Now we know there's a weird behavior in the service. Looking back at my expectations, I built an evaluator to track if the number of tags are in range. I think I still need to refine that a little. Here's my current metric and evaluator setup. First, I define a new metric, tag total, that will record the number of generated tags. Then, I build a simple evaluator, which records the length of the generated tags array. Then, we record a measurement using a scoring value instead of a pass-fail value. Using the tag total and tag count metrics, we evaluate range compliance and the distribution of generated tags. We can follow a similar pattern for checking the number of words in tags. Here, we check each tag for a space, then return a failing metric if it does. Identifying a literary genre is equally straightforward, assuming you're looking for a known set of genres. We check the book tagging service for known genres, then compare each of the generated tags for a match. Our evaluation is really filling out. We can already measure 3 of our original 5 expectations. And our evaluation report provides a rich picture of how our tagging service is performing. We track our 3 expectations using 5 aggregate metrics. Here, we can see the distribution of tags, along with range compliance and containing genre tags. Using our hill climbing methodology, we've iterated on our instructions for the service. Here's where we started at the beginning. After several updates to our evaluation and multiple runs through our loop, and we can track each change to our instructions by an expectation we added to our evaluation to verify that change. When you take our hill climbing feedback loop and center your development process around it, we call it evaluation-driven development. But we're not done getting our service up to spec. We still expect our tags to be informative, relevant to the book, and helpful for browsing your library. Here's Yada to tell you about model judges and how they'll take your evaluation to the next level.
Thanks, Rob. Model judges are how we measure qualitative metrics at scale. Let me show you how to build and refine one. Let's take a look at a concrete example. Here's a review of Alice in Wonderland that Rob wrote in Book Tracker. And here are the tags that our service generated. 6 tags, single word or hyphenated, with tags identifying genre. Every quantitative metric we built with Rob passed. But look closer. Overrated and pretentious doesn't describe the book. They describe how the reader felt about it. And whodunit isn't even the right genre. The model picked it up from riddles he never answers. It latched on to the language of the review without understanding the book. Our metrics are passing, but they're not giving us the right signals back. But I think we can ask the model to help us here. If a person can read these tags and tell us which ones work, maybe a model can too. Oh, nice! The model actually captured that certain tags are not helpful. I think I can ask the model to evaluate all of the tags that my feature generated. And that's exactly what a model judge is. A model judge is a language model used to score your feature's output. It gives you a subjective rating, the kind of judgment call a person would make, but applied consistently across your entire dataset. So let's talk about how this works. Here's the model powering your intelligence feature. Our book tagging service runs on device because it needs to be fast and local for every user interaction. You can use a second model as a judge to evaluate your feature. Your judge should be at least as capable as the model you're evaluating. In our case, we can use a more capable model from private cloud compute. The model judge has a few key components. The instruction tells the model it'll be given book reviews and how it should evaluate it. The feature input is the prompt given to the feature being judged. In our case, it's the book review. The feature output is the tags our service generated. And finally, the scoring guide tells the model how to evaluate and score the feature. The evaluations framework handles most of this for you, so you can focus on the scoring guide. Putting it all together, here's a simple model judge. We've defined a tag quality metric on a 1 to 4 scale, with each level describing what that score means. An even number of options prevents the judge from defaulting to a neutral middle score. 4 levels provides just enough distinction without diluting the meaning of each rating. And finally, we've specified private cloud compute as our judge model, giving us a more capable evaluator than the on-device model we're evaluating. In the evaluations framework, a model judge is just another evaluator. It conforms to the same protocol as the quantitative evaluators and produces the same metric type. So you can mix them freely within a single evaluation. All right, let's run it. Every sample received a 3 or 4 quality score. Let's go back to our Alice in Wonderland sample. the model judge gave this a quality score of 3. If we look at the rationale, we can identify that the model flagged whodunit and detective fiction as not relevant to the book. But we also expected it to flag all of these other tags that either reflect the reader's opinion or are not helpful for browsing. With model judges, rationales are essential. They give you a window into why the judge scored what it scored. And here's the thing. By the scale we wrote, the judge is actually right. Every tag connects to something that the user wrote. The judge is faithfully following the scoring guide we provided. We meant something specific by relevant and useful for browsing, and the judge interpreted those words differently than we did. By asking the model to provide judgment for my feature in my place, I expected it to provide a similar score to how I would have scored these tags. When there's a mismatch between the model judge and us, we can refine the model judge until it can stand in for our own judgment. Looking back, the problem with our first model judge was that it was too broad. It was asking 2 different questions. When you find yourself disagreeing with a score, you should try and see if you can split the questions. In our case, relevance and usefulness are actually 2 different metrics. Let's take a look at defining relevance as a score dimension. When we say the tags are relevant, we mean that each tag describes the quality, theme, or tone of the book itself, rather than small details or a reader's personal reaction. And we can write that as a description for a score dimension. To score these tags, you would walk through each one, identify which tags are bad, and which are good based on whether or not they meaningfully describe the book. You would repeat this for every tag. In this case, all of the tags are good, which earns a score of 4 on our 1 to 4 scale. You would repeat the same process to define each scale in the scoring guide. And that's our relevance metric with the metric name, description, and scale that the model judge can use. I can use the same process to define usefulness. Now, I can add both dimensions to the model judge evaluator. But dimensions alone aren't enough. They tell the judge what to measure, but not how to think about your app. Without that context, a judge evaluating tags for book tracker might treat a reader's criticism as a valid book descriptor. It has no way to know that book tracker is a personal library and not a review platform. And that's where the model judge prompt comes in. This is an example of a model judge prompt. We can tell the judge it's evaluating tags for a personal library app in the instructions, format the response in the evaluation target, and pass the expected tags as reference for the model to compare against. For more details on model judge prompt, please see our documentation. Now that our model judge has the context it needs, let's rerun our evaluation. In place of quality, we now have a relevance and usefulness score. And here's the evaluation result of our Alice in Wonderland book sample. Notice how the 2 rationales separate the diagnosis. Relevance tells us what kind of tag is wrong, and usefulness tells us how the wrong tags fail at browsing. With these results, I now have a clear path forward. I can update my book tagging service instructions, run the evaluation again, and watch the scores change. And that's the feedback loop Rob walked us through, now powered by qualitative metrics.
When are you uploading the test flight?
Well, Rob, I've been a little busy.
Let's wrap up with a few best practices for evaluating your apps. Start small. A focused data set of 20 to 30 samples is a great place to get started. Spec out your app by thinking about how you want the model to behave. Use heuristics to measure quantifiable traits. These rule of thumb metrics are a great way to start understanding your feature. The rule of thumb is, if you can measure it in code, then it's quantitative.
And if you can only describe it in words, then you need a qualitative metric using a model judge evaluator. Start simple with your model judge. Define your scoring dimension, run it, and read the rationales. You'll learn more from a single run than from hours of careful planning. Use rationales to drive your next change. If the scores are all the same, your question's too broad. If you can't isolate the problem, split the dimensions. And if the judge doesn't understand your app, add context.
Well, I guess we should get back to work.
Be sure to check out our documentation.
And our sample code.
And check out our other videos featuring the evaluations framework. Improve your prompts by hill climbing with evaluations and create robust evaluations for agentic apps.
Later.
Bye!